I'm Kristina Jackson. This is Bill Harris, and today we have on Dr. Heidi Lai. Heidi has recently joined the Fatty Acid Research Institute, or FARI, as an associate scientist, where she studies how blood levels of fatty acids relate to long-term health outcomes. She holds a PhD in food science and nutrition from the University of Leeds in the UK, received her postdoctoral training in nutritional epidemiology at Tufts University in the US, and has worked as a research advisor in Imperial College London in the UK again. Heidi has also been an active member of the International Fatty Acids and Outcomes Research Consortium, or the FORCE group, since 2018, which FARI works with quite a bit. Thank you so much for coming and talking with us, Heidi.
Yeah, I'm really glad to be here today to talk about this topic. It's really exciting.
Yeah.
Right.
So you've been in this field, in this world through your training and post-doc and all of that. Can you tell us a little bit how you got to this place and how you got interested in fatty acids?
I guess it was really during that formative period when I was doing my postdoc. It was during that time when I got introduced to fatty acids and the methods which we use to link fatty acids to chronic diseases. Before that, I was mostly just focused on dietary polyphenols and cardiovascular disease. So there are some similarities there. But yeah, Dr. Mozaffarian is brilliant, and he really taught me a lot about this topic. And after I kind of left to explore other fields, I guess you can say I couldn't really get away from it because I was part of the Fatty Acids and Outcomes Research Consortium, and I kind of stuck with it. That's where I met Bill, and we collaborated on quite a few papers together. So I led a paper on trans fats and type 2 diabetes, which Bill and Nathan are part of. I think, Bill, you led a paper on omega-3s and mortality. Yeah. So it was through those projects that we got to know each other a little bit more. So when I kind of was thinking about returning to the field, I reached out to Bill, and that's how I joined FARI.
Yeah, that's great.
Great.
Great training.
One of her first assignments when she joined up with us was to take the lead on a paper that we're going to talk about today.
Yeah.
Which is how omega-6 levels, red blood cell omega-6 levels, associate with inflammation or inflammatory markers. Very, very timely topic today, given the current emphasis in the U.S. on healthier diets and some concerns about seed oils. Why would seed oils be an issue for omega-6, Heidi?
Well, actually, there's a lot to talk about when it comes to kind of the topic of seed oils. And this is because seed oils predominantly contain omega-6. But I guess I want to emphasize that we see a lot in sort of social media that omega-6 is kind of just mentioned as if it is one single compound, when in actual fact, it's actually a class of fatty acids. And it consists of predominantly linoleic acid and arachidonic acid, so LA and AA. And so LA is actually an essential fatty acid, and we need it to survive because it's really essential for maintaining the structure of cell membranes. We can't live without it. If we don't have it, we experience deficiency, though this is actually pretty rare in developed countries where we have lots of food available. Deficiency is only really seen in countries that have prolonged malnutrition. In certain cases, we've seen it affect growth stunting in children. But this is usually not a problem in the US and the UK or the countries that don't experience malnutrition. And so as Bill mentioned, seed oils such as soybean oil, cottonseed oil, safflower oil, the main sources of omega-6. We also consume it sort of from nuts and seeds, walnuts, sunflower seeds, almonds. And generally, the recommended intake is about 5 to 10% NDG. So 11 to 22 grams, which most Americans kind of achieve or even consume even more of. And so this is how sort of omega-6 is linked to seed oils.
Yeah, good.
And they're often those oils, as we've said before, are used for frying a lot of things.
Yeah, so they're used for frying, and I believe they're also incorporated in processed foods and fast foods because of how cheap they are, and sort of just greater availability compared to the alternative that I see mentioned quite often. So cold pressed oils, which are mechanically pressed, rather than refined oils, which goes through a series of process, sort of extraction, and then removing impurities, removing odors, and also sort of, I think some of them do add antioxidants as well to improve shelf life and stability. So yeah, it's incorporated in a lot of ultra processed foods, chips, baked foods as well.
Mhm.
So yeah, not just in cooking.
Yeah, and is it the same in the UK as the US? Similar, that those seed oils are used for?
Yeah,
And
yeah. Though I think in the UK, when I look at food labels, sometimes they also use palm oil, rapeseed oil. So that probably has a different fatty acid content compared to corn oil.
Mhm.
in the US.
And just another quick question on like the food science side of it. The cold pressed oils, is that primarily olive and avocado oil?
I think so. Yeah,
Are there any others? I can't think of any.
not so common in others, I think. So mostly just olive oil. Yeah.
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 What do we know about the relationship between the intake of linoleic acid and blood levels of linoleic acid?
Well, I guess based on what I know, the relationship between dietary linoleic acid and blood levels, I think it's linear-ish, but it kind of comes to a plateau. So when you consume up to a certain amount, your body starts to regulate that level. So it doesn't sort of saturate. And this is a very common thing that we see with nutrients, other nutrients like vitamin C, as well.
Okay. Yeah. So are blood levels a pretty good indicator of intake?
I would say so, because it mostly comes from diet. We don't get linoleic acid from anywhere else.
Yeah, we can't make it. So
We can't make it. Yeah.
it's got to
It's-
come from diet. Yeah.
What's any level there? It's at the beginning of the pathway for the
Yeah.
elongation and desaturation. So linoleic, I think it's a little less of EPA and DHA have a very strong association with intake, but even there's a lot of variability person to person. And linoleic is less strong than EPA and DHA. And I think part of that is it's coming in at the beginning of the pathway. So we're not making it anywhere in our body. It's from our diet and our stores probably. And then, but it is getting used to make other fatty acids. So that part of the equation could be part of what's changing level. I mean, both of those things, intake and its use, are somewhat affecting the levels. We're just not, it's hard to tell.
It's really
what's what.
Yeah, because because when I was at the fatty acid research symposium earlier this year, there was a talk on omega-6 and inflammation, and one of the papers that really stood out to me, it was a paper that looked at feeding people LA, if I remember correctly, and then seeing if the downstream metabolites would change in the body. And I think the results were actually quite unexpected, at least for me, because the levels didn't really change as much as one would expect. The levels of the AA-derived metabolites didn't really change at all.
Yeah.
And if I remember correctly, some of the omega-3 levels went up as well, which was something you wouldn't expect. So actually, the process in the body when we consume LA and how it gets converted to AA and other subsequent metabolites is really tightly controlled.
Mm-hmm.
So it's not just it's not like if I ingest a huge amount of omega-6, that's all going to get converted into AA and potentially other pro-inflammatory metabolites. That's not actually what happens.
Yeah, and that is, I think that's one of the pillars of this idea that omega-6 is bad. Little lake is bad because the idea that some people have is the more little lake you eat, the more arachidonic acid you make. And that's just experimentally shown not be true, particularly in humans. You can raise little lake intakes tremendously, or you can cut them almost to nothing, and the plasma arachidonic acid levels are just absolutely flat. So the idea that LA drives arachidonate levels is really not true. And so one of the false ideas about the omega-6 is pro-inflammatory. Remember where the pro-inflammatory connection came from?
Well, I think Bill, you might probably be more familiar than me, but I'll start off the story anyway. So I think,
I've been around longer. That's true. I kind of remember the days, and I think it goes back to probably Bill Lettens and some of his work early in the late 1970s when the prostaglandins were discovered, and from saying that they were made from arachidonic acid and they had pro-inflammatory effects. And if you blocked the conversion of arachidonic acid to its prostacyclin, then you got an anti-inflammatory effect. So that made people think, oh yeah, it's the arachidonic acid that's pro-inflammatory. And that's in a sense right, but it's also in a sense wrong. It's also very, very naive because there's so many other metabolites besides just a prostaglandin that are made from arachidonic acid, some of which are anti-inflammatory. So yeah, the idea that omega-6s are pro-inflammatory is really stuck in the nutrition culture, or at least maybe the blogosphere or whatever, the influencer world. But that's then your study addressed. So why don't you tell us about the study that you did?
okay, yeah, let's talk about the study.
Can I give the name and the journal so people can find it if they want? Here we go.
Oh yeah,
Nutrients, 25, and the title's Red Blood Cell, Omega-6 Fatty Acids, and Biomarkers of Inflammation in the Framingham Offspring Study. So that should be publicly available.
How about this? Why don't you just do this? Watch this.
Oh my gosh. Are we getting fancy?
We're getting fancy. I think I am. Welcome, select the tab. Well, wait a minute. We'll say,
maybe we don't need to get fancy.
Maybe we don't. Well, here we go. I figured out how to do it. So this, I think, is a picture of the. Here we are.
Oh,
so yeah. So who are these other authors? I know I'm the last one.
Nathan Ryder, who did most of the statistics, Dayton Cento as well, and Penny Chris Edison is one of the experts in fatty acid. Well, yeah.
Okay, that's the paper, and it's published in Nutrients, and so people can look that up. And I can stop sharing. I think. Well, just keep talking. Just talk. Yeah. There it is.
Let me tell you about how the study was actually done. So, so we at Fari we have lots of data, and one of the data sets that we have is from the Framingham Heart Study. So this was initiated in 1948, and we sort of picked sort of like a sub-cohort called the Framingham Offspring Study. So children of these people who were part of the original Framingham Heart Study. And there were about nearly 3,000 people, and the mean age was, they were middle-aged, 66 years old, half of them were female, half of them were male. And every time they attended the examination cycles, the blood samples were collected, so the urine samples. And so we were able to measure the red blood cell LA and AA levels from these participants. And at the same time, from the serum, we were also able to measure 9 different biomarkers of inflammation and 1 biomarker from the urine. And so this is quite a wide panel of inflammatory biomarkers. And they kind of play various roles in acute and chronic inflammation, which I think is something important to differentiate. And also, these biomarkers, some of them are pleiotropic. What that means is they can exhibit pro-inflammatory effects as well as anti-inflammatory effects. And that's really dependent on the condition at the time they're in. So what the cell needs, what signals are coming through, etc. So it's very, very complex. So for example, TNFR2, it's a signaling molecule, and it's both neuroprotective and conflictingly also promotes cancer growth. But then if you really kind of zoom in to the experimental studies, there are also some cases where anti-cancer activity has been seen. So it's really contextual, all these mechanisms that we're seeing. And if we consider CRP or IL-6, MCP1, ICAM1, these are more general markers. So the main roles are to facilitate white blood cells, to inflamed or infected cells, to try to kind of quell your inflammation, put out the fire, if you will. And so whenever you get an acute trauma, these levels would rise really rapidly. And then once that resolves, the levels kind of just go back down. Some of them reflect specific types of inflammation. So, for example, LPPOA2, it specifically represents vascular inflammation, so blood vessels. And then we've got the osteoprotogerin, so that's related to bone health. And then we've also got something called isoprostanes that's related to oxidative stress. So a very, very wide panel of inflammatory biomarkers that represent, the sort of systematic inflammatory process.
Yeah. Thank you for breaking those up into those categories because number one, like the fatty acids are complicated, the immune system's beyond complicated. And so anytime we're talking about inflammation or immune system, it's like we know this much about it. It's so dynamic. When you measure blood at a point in time, it is a point in time and it's supposed to be up or it's supposed to be down. And so we just have to keep that context that we're looking very broadly. These are all fasting samples, I assume.
I think so, yeah.
So that helps with some of that variability. And they can do different things, but we do see kind of in the extremes if these are higher typically or, lower, those do indicate the system is activated or not. And then we kind of think overactivated immune systems, that is, you don't want that happening all the time. But just that like a level of humility about what inflammatory markers mean is always good. Because they are tricky.
Yeah, so because
the standard narrative of omega-6 are pro-inflammatory was true, what would you have expected to find in your study?
So like Kristina said, we're kind of taking like a photo, except we're doing this using blood samples and urine samples. And if omega-6 were pro-inflammatory, we'd expect to see a pattern where if there are higher levels of LA or AA, the levels of these biomarkers would also be high. So we're looking at correlations at this point. But then there are other factors that might also affect these levels. And what we really want to try and see is the independent correlations between these omega-6 fatty acids and inflammatory biomarkers. So we adjusted for quite a few things in the model. So these are things that often would influence the levels of either biomarker and the fatty acids themselves, or either or. It depends. So by removing all these noise, we're trying to see whether there's an independent correlation between omega-6 and inflammatory biomarkers. And surprisingly, or maybe not so surprisingly, we did not see any positive correlations at all.
Mm-hmm.
So,
Yeah. I mean, it was not only that you didn't see any direct relationships.
yeah. And what we saw instead was that LA was actually inversely associated with CRP, IL-6, ICAM-1, and MCP-1, and P-selectin as well. So these correlations, they were weak, but they're there and they're statistically significant. And this was also the same for AA, which was inversely associated with IL-6, ICAM-1, MCP-1, and osteoprogerin. Again, weak associations, but statistically significant. And I do want to point out that we didn't see any association with isoprostates, which is the biomarker of oxidative stress. So we didn't see anything going on.
Well, now that's important because the oxidative stress. This was a measurement of molecules in the urine, right? That would imply increased oxidative stress, and that's, I think, one of the stories that gets spun around seed oils is by heating them repeatedly and letting them go for hours creates pro-oxidative, or it oxidizes the seed oil. And so when you eat it, you theoretically would have a higher oxidative stress load in the body. But here you found that there was no relationship, or it was actually inverse. I mean, no relationship between the level of red blood cell, linoleic acid, or arachidonic and oxidative markers. So that's I think, important data point. Beyond just the inflammation, there's oxidation. And the oxidation was not increased by having higher levels of omega-6.
Yeah. So the findings really just go against the narrative about that omega-6s fuel inflammation.
Right.
Yeah. And
Go ahead, Dan.
I was just thinking about, like, we're looking in Massachusetts, essentially, US, range of average intakes. So, and what we've seen is the average intakes do tend to land within the 5 to 10% of energy from what I've seen. And so, like, I guess just putting in the context, when we see these linoleic acid levels that are affected by intake, we are within the bounds of what has been shown experimentally to be healthy or not disease inducing, as far as we can tell. So even within, like, we are not looking, mostly there are not people that are at really, really, really high levels for the most part in general.
But we've looked in other studies at omega-6 levels, linoleic and arachidonic acid levels in much larger populations, like the UK Biobank. There are hundreds of thousands of people. And we've looked at relationships with not inflammatory markers, which they really didn't measure in that study, but they measured things like total mortality, death, risk of death. And we found that the higher the levels of linoleic acid in the blood, the lower the risk for death.
Oh, yeah. Yeah. I guess I wasn't going, that it would be where you thought I was going. I was going into the way of, there's a general thought that we are all eating so much.
Yeah.
Like us. And it's just like, it's not really true. We don't, and we don't have great ranges for blood levels yet, I would say. That would be my other question of, like, what's an average blood level? Do you know what the blood levels in this study were? I mean, for kind of averages, and starting to think, like, kind of like the omega-3 index, we have, 8% means this.
Yeah.
Where with linoleic acid or arachidonic seems to be too controlled to matter.
Yeah. Absolutely. Right. I was just looking at, I've got the paper up here, Heidi. It's about 11%. When you look at the red blood cell, linoleic acid, it's about 11% of the fatty acids, and arachidonic is about 16 or 17% of the fatty acids. And it varies, linoleic probably varies, from a low end of, maybe 8% up to maybe 14%, that range. So having a higher level of linoleic acid, it looks like it might actually be better for you. That's what's concerning, I think, about these calls to get away from seed oils, is that we're lowering linoleic acid intakes, the evidence at this point says that's going to increase risk for cardiovascular disease, diabetes, and total mortality, which is not a good thing to do.
Yeah.
It kind of reminds me of the trans story in a way, where we, in the 70s and 80s, we thought, well, let's replace saturated fats with trans fats because they're not harmful, but they give foods the right mouthfeel. And then we turned around in the 90s and said, uh-oh, that one was, hopefully we don't go down that road again with linoleic acid.
Yeah. And the one thing that I wanted to point out why those large studies that you mentioned, Bill, is important and how it links to our paper is because death, diseases like death, CVD, cancer, they might be linked to chronic inflammation. So that's where the link is, why we want to look at specific diseases and mortality, risk of death, and how that links with LA. And we've done quite a lot of studies in FORCE as well, looking at omega-6 and CVD. And I think the association was inverse with LA, but neutral with AA.
Right.
And there was also another paper in the UK Biobank that just came out this year that looked at cancer, so the overall cancer and different cancer types. And I think out of 19 different cancers, LA was inversely associated with 14 of them.
Yeah.
Yeah.
And diabetes is where it pops up all the time.
Diabetes.
That's we've seen it's very consistently inversely related with diabetes risk and metabolic outcomes.
Yeah.
We're trying to think through that.
You mentioned the FORCE coalition that we've both been involved with. Are they doing anything with the omega-6 story? We've done a lot of omega-3. Anything omega-6 coming up from the FORCE group?
So you've looked at the same question in UK Biobank. So right now in the FORCE group, we're including the UK Biobank with, I think, 29 other cohorts.
Wow.
And we're trying to pull these findings together. So I think it's going to come up to maybe 300,000 people altogether. And then we're going to see how linoleic acid and arachidonic acid is associated with the risk of death, CVD death, cancer death, and other types of death. So that's ongoing right now. It's very exciting.
Well,
wow.
That's going to be powerful.
Yeah.
That should make a big hit. Because I assume we're going to see the same thing we saw in the UK Biobank, a single cohort and 29 cohorts. Very favorable relationships, higher omega-6, better outcomes, health outcomes. So if you do it in a much wider net, many more studies, not just one in the UK.
Yeah, exactly.
And I should mention, you are physically you're talking to us from London right now, are you? Yeah. Use a little geographic orientation here.
That's true. Yeah. Yeah. I think it's interesting. My other thing that I keep thinking about with the seed oil conversation is usually it starts with that overall over the years correlation where seed oils have increased in the food supply. And so of all these diseases, that's the general starting point for a lot of these conversations. And I get, like we mentioned, this is a cheap fat. It is a cheap calorie source. And that alone is a major driving factor of so many of our chronic diseases is overnutrition, over calories. And it's when the content of the actual species of fatty acids are actually showing these pretty strong protective signals in the context of overnutrition, it's kind of impressive. But I think both of those stories are true. It's like if we ended up we started to have cheaper sugar and cheaper fat over these decades, and that overall issue is probably driving a lot of these chronic diseases on its own, regardless of if it's seed oil or not. Like that context, I feel like is missing all the time.
Yeah.
Yeah.
Good point.
And when people talk about sort of taking out linoleic acid or seed oil, where are you taking them out from? Are you swapping your cooking oils, or are you actually cutting down your chips, your popcorns, your cakes? Those contain linoleic acid, as well as a lot of sugars, carbohydrates, and other things like salt as well, which is going to influence your health, is going to influence your weight. I was going to link what you just said, Kristina, to another project that we're looking at. So we wanted to find out if linoleic acid is actually associated with body weight and the amount. That's one of the concerns, isn't it? So yeah, lots of things going on right now. Yeah.
And nutrition is just super complicated. So it's great when you have lots and lots of data. It helps you kind of see these larger trends. It's great that we have Force and Fari starting to combine all of this data to get bigger stories and to really solidify what we're seeing and have more confidence in it. To answer the questions that people are asking, it's whether or not you want to hear it. It's this is what we see in blood and in hard outcomes. It's pretty solid evidence.
Yeah, I think,
or I guess these are inflammation outcomes, but we have hard outcomes as well.
Yeah. I guess the takeaway
By hard outcomes.
Oh,
yeah.
Yeah. You can talk about the difference, like evidence levels of the outcomes.
Oh yeah. I mean, yeah, I was gonna say, I guess the nuance that people should really think about is that omega-6 is a class, and each of these individual fatty acids, they have different biologic effects. And inflammation is there's a difference between acute and chronic as well. We need acute inflammation because it helps our body heal, but what we don't want is chronic inflammation. So there are lots of things to think about rather than just honing in on zooming into one specific mechanism that Bill mentioned, the COX pathway, where AA is converted to pro-inflammatory metabolites. If you kind of just zoom in on that, and that's also where the omega-6, omega-3 theory came from as well. I guess that kind of evolved from there, and a lot of people started looking into the ratios. I don't know what to talk about, but I think that's like another huge,
the whole another. We'll bring you on.
Yeah, but yeah, but yeah, people started looking into these ratios. But then again, the nuance with these ratios are, if you have low levels of both, it's a ratio of 1 to 1, because a ratio is something relative to something. So we really need to start thinking about how much we're actually consuming rather than just focusing on the ratio, number one. Number two, LA, a lot of the evidence right now shows that LA is actually has a beneficial effects on health. So it really isn't fair to compare omega-6 LA with the omega-3s because they're both great. One of them doesn't need to be a villain. I suppose that's what I want to say.
Right.
Yeah. And it has a little bit of an artifact because it makes the range bigger, the number range. So the effects look stronger with the ratio, but it's almost always driven by the omega-3 side.
Yeah.
The range of omega-3 levels is smaller, so it's harder to see that relationship. So there.
Yeah, I think in that paper, Heidi, you mentioned the cancer paper, 19 cancers that Tom Brenna's group looked at. And I think they concluded higher levels of linoleic acid were favorable, reduced risk for cancer. Higher levels of omega-3 were favorable. It's just that the omega-3 favorableness was greater than the omega-6 favorableness. So the ratio was unfavorable. So it's very confusing. So people say, well, therefore, look, the ratio was bad. Well, no. The ratio was bad, but it's a meaningless metric, and I don't want to get on that soapbox. Yeah. But so stop me.
That's so crazy. Yeah, I think all of these things you're bringing up are really important when we're looking at the research and trying to take what's being talked about and look at it in a really rigorous way. And you can see where all these things come from, but then they get very distorted once they get oversimplified. And
Yeah.
so you've mentioned another paper, like bringing together all these other cohorts. Are there any other studies or questions that came up from the results of this paper that you're tracking down?
I mean, the two projects that I mentioned kind of ties in with this paper. The way I see it is this paper is sort of like the exploratory groundwork for the papers that look at LA and BMI and also LA and mortality, because BMI and mortality, they address chronic inflammation. What we're doing with this current paper is, like I said, just taking a snapshot or a photo and looking at patterns. And for each person, that photo may vary. Maybe, so there are a lot of individual variations. And it's also cross-sectional. So we can't definitively say X causes Y. That's not how the study was designed. And so by doing all these follow-up studies where we use statistical methods that incorporate time to events, we will be able to draw some sort of statistical inference to say whether something is associated with these health outcomes, and possibly based on the mechanisms from all these experimental studies, if there's a possibility that X causes Y. So it's all very complicated, and I think people really need to understand sort of the different layers of evidence behind all of these statements that we're making. Experimental studies, they're often very good at teasing out these mechanisms, zooming in. But if we over-focus on them, we're really missing sort of the bigger picture of how, because the body functions, well, to me, very mysterious ways. At any given time, there would be hundreds, thousands of things going on. So it doesn't make sense for someone to really just zoom in to one specific pathway and say, oh, this is what's happening, so that must be happening all the time. So by looking at, observational studies and also evidence from trials, it's much more scientific and grounded, I would say, to examine sort of all of these evidence altogether to see what the big picture is. And I think that's what people kind of need to understand. There's a lot of science and there's a lot of research that goes on behind these statements, and a lot of the times it's not that simple.
It's never simple. Yeah. And I think I didn't answer this before, but what you're talking about, these just different kinds of studies, and the hard outcome studies are death and a disease state that's been assigned by a doctor, and mid-range is well, can we look at like what's happening in between, like a blood level of fatty acids or a blood level of inflammation markers, to try and link what's happening. And then you go even deeper, like you said, the experimental studies get even more into the details. But once you get in the details, again, you're missing everything you're not looking at when you're trying to get it down to one variable. So you got to look at everything. And so far, what we keep seeing is this signal of omega-6s and omega-3s as cell status markers continue to be consistent in predicting beneficial health outcomes if you have higher levels of both of those things.
Yeah.
Which is kind of hard. The story is so nice, the good versus evil. It's just like not.
It's very hard to come out of that. I remember when I was doing my undergraduate, and I actually did try and look this up in a very old textbook. It was advocating for a low omega-6 and omega-3 ratio.
Oh yeah.
This is really deeply ingrained. It's very difficult to come out of. And yeah, I've learned a lot since working on this project, and it's changed a lot of my viewpoints as well. So
that's good.
Good. That's
You got to be flexible.
Yeah.
Thank you so much, Heidi, for working with Fari, getting this paper out and continuing to like collect this data so we can answer these questions. It's great.
Yeah, thank you. Thank you for having me.
Yeah.
But
All right. I think that's it for today. Thanks for
Great.
tuning in. Is that even a thing we do? Tuning. That's a radio term.
not already. Right.
Yes. So check out this paper and we'll be back soon. Thanks.